Hello, my name is Jonathan Saysamone, and I will be overviewing STEM education module development utilizing aquaponic systems in Uganda. So to give you a little background, there are increasing sustainable issues in developing regions of the world, especially Uganda, and these issues are food production and lack of a clean water supply. And I believe that it's very important to be educated on these matters. So I figured that implementing an educational system in Uganda's schools will allow future generations of engineers to tackle these sustainable issues. So my goal is to develop an educational program revolving around aquaponic systems. So these are the presentation overviews. So what is an aquaponic system? Basically, an aquaponics system utilizes fish and plants symbiotic relationship. So what I mean by that is the fish waste provides nutrient-rich water as shown in this picture, and this is given to the plants, and the plants uptake those nutrients, which filters out and cleans the water, and then it's recycled back into the fish tank. So implementing aquaponic systems. So there are lots of technical difficulties when it comes to implementing an aquaponic systems, especially in a classroom setting. There has to be lots of attention to maintaining the system because of possible water balance or pH or dissolved solids. And this could be especially difficult for this school if they lack the resources to do so. And also, you have to consider the scale of the aquaponic system. So we want this aquaponic system to be in a classroom setting. So definitely we're going to need to scale down this system so it can be used for educational purposes. So we need to consider the measurements and the scale appropriate for the classroom size. And hopefully to the greater extent, we can use already available resources to construct these aquaponic systems. So educational program opportunities. So there are lots of components and topics that aquaponics uh, cover. So such as biology, chemistry, technology, and engineering. And there are also little sections such as the sensors that are needed to monitor water quality. Those are good lesson materials to use to educate, so you can teach kids how to read pH. And also another very fundamental core concept is photosynthesis. So the plants in the system go through photosynthesis for this to work. So that is also something good to cover. So for creating these lesson materials and activities and assessments, we needed something to work off of. So we decided to look up education standards for our material. And as shown on the left, the first standard is use a model to illustrate how photosynthesis transforms light energy into stored chemical. Well, this is pretty simple. So we created a homework assessment on the left, and this is just very basic, very fundamental photosynthesis. And if the students can grasp that concept, then we already tackled one of the goals shown on those educational standards. And you can see this is the first drafted lesson plan, and this is what we would go about to, introduce the kids to photosynthesis, and then at the end we would just assess their knowledge on the subject. So this is more drafted material. So we decided to use lesson objectives so that the educators know what the students have to, like, what skills the students or what the students should be able to do by the end of the module. And then by the end of the module, hopefully we will give them assessment material. And this assessment material is like is in a quiz format. So on the right, you have just sample questions, and these questions are very straightforward, and these questions should cover them, like, core points of photosynthesis, and I didn't want to have a complex question because I just want to be very straightforward with the students, and I just want them to, like, you know it or you don't know it type deal. And also with these lesson materials, we also incorporated hands-on activities because I believe hands-on activities are very effective, is a very effective delivery method for education because, I don't know, when I was in school, I was like doing hands-on stuff. So I figured that the kids would feel the same. Uh, Broader educational outcomes. So yes, throughout this module, the students will have more of an understanding of aquaponic systems and technology, and hopefully that steers them to a career path of their choice that they like. But also you have to consider that this is also a great opportunity for teachers. The teachers have technology within their classroom, and they have the opportunity to use that technology to educate other students. And also, uh, non-academic related skills, like skills necessary for pursuing any career, basically, is, responsibility, critical thinking, teamwork, and problem solving. And that's with the hands-on activity as shown. Each student in the group is assigned a role. So I created basic roles: scribe, timekeeper, data collector, and these roles give the students a sense of teamwork and responsibility. They have a role to fulfill, and they need to work together to manage that. So in terms of future work, there is definitely need of refinement and editing of the current drafted materials. By no means is the drafted material now final. There's still lots to polish up. The format is probably not as pretty as I want it to be. And additionally, we want to put this drafted material to the test. We want to send it to the Ugandan school and get feedback for it and see what else we could work on for that. And additionally, like if this does make it through, the implementation of more technology or maybe more topics to address in education would also be considered. And so these are some of the acknowledgments. I would like to thank C-Step and Kupo for giving me the opportunity to work, to research over the summer, and a fellow acquaintance, Maya Cliff. She is the initial aquaponics system designer, and without her information, this wouldn't be possible. Thank you.